Today we're finishing up the chapter with section 12.5 and 12.6, direct variation and inverse variation. The homework will be 559, 1 through 23 odd, and page 563, 1 through 23 odd. New vocabulary for the week will be direct variation, constant of variation. K stands for our constant. And let's just write in our equations too. This kind of equation is a y equals kx, and inverse variation is y equals k over x. Okay? Our constant of variation is that k. That's what we refer to as k. So it's that number right there. All right, let's get started. So, we are writing equations and using equations involving direct variation. You have seen equations like this. We just didn't call them direct variations. They also call them proportional equations. So direct variation means when the dependent y is proportional and varies directly to an independent variable x. It's basically your y equals mx plus b without the plus b. It's y equals mx, okay? So if this is the direct variation equation, then let's look at some other equations that might be. Take a minute and see if you can recognize which ones are direct variation equations in the form of y equals mx. Now, the thing I want you to notice is notice the power of x and notice the power of x and yeah, okay, so let's pause the recording and try the next few on your own. So, let's check our work. Y equals 4x is a direct variation equation. Y equals negative x. Let's like y equals mx, it's just negative 1 is your m. Okay, is 1. However, y equals 5x squared is not. They are not quadratic equations. It's to the first power. However, y equals 2/3 x, that's in the form of y equals mx. Now, the next one you have to see, can you get it? If you get y alone, will it be in the form of y equals mx? So I'm going to since it's y divided by x, I'm going to multiply by x. Multiply both sides to get it alone, and then we get y equals 7x. So yes, this is a direct variation equation. It's just written differently. Y equals x cubed is not. Let's try the next one. I'm going to multiply both sides by 3, and we get y equals 3x. So yes, that is a direct variation equation. And of course, the square root of x is not. Okay? You need to write your notes down, pause the recording. All right, so here's how we do it, how we write our equation. We're going to use this exact writing. It never changes. So when it says y varies directly, we're going to be writing y varies directly with x. Whenever you see this, y varies directly with x. And then they're going to ask you to substitute in. So y equals, it says y is 21. They want you to first find your k, your constant of proportionality. 21 is your y. K stays there, times 3. And then we're going to get the k alone. And so we're left with k equals 7. Once we know what that is, we rewrite it, y equals kx. We substitute in y equals 7x. And then this is our direct variation equation right here. So if they want us to just write that, that's what we do. But then it says find the value of y when x equals 8. So I use that, and then I substitute in y equals 7 times 8, so y equals 56. So in this case, they gave us two values we had to substitute in. Okay, so we could find the K. Our goal is to find the K. Once I find the K, I write the direct variation equation. Okay, that's like your y equals mx with the m in there. Once I know that, they give us more values to substitute in and see if we can use it. All right, let's try another. All right. Here's a word problem. Okay, let's try a word problem and look at what direct variation. So basically, our direct variation equations, if we went back to this last problem, it says, you know, we could basically set this up like a proportion, right? Where we're doing y to x equals y to x, right? They're giving us two quantities. And each time you'll notice if it's 21 over 3 is equal to the unknown 8. And so we can figure that out. We know that when you divide this by this, we know it's a 7. That's our constant of variation. Or we can do our cross product. So it is a proportional equation. So when we get something like this, it takes 5 cups of flour to bake 65 cookies. How many cookies can be made with 7 cups? We can say that X stands for our cups and Y stands for our cookies. The result. What is the depender of cookies depends on the independent flour, right? So I can make this in the form of y equals kx. So I can do y equals, we can say there's 65 cookies for 5 cups. Okay? And then we find out what our k is. Now I take that 13 and I substitute it in, and now I'm going to say how many cookies can we make with 7 cups. So I substitute it in. And again, I mentioned that this could be done. Direct variation equations are proportional. Okay? So let's just, again, if I'm doing y over x equals, because let's just say I go y equals k over x. Let me show you why it's proportional. If I were to get k alone, I divide both sides by x, right? So we get y over x equals the k. And if they're both equal to that same k, then we can set them up as such. Y over x equals y over x. Basically, if I want to call this cookies to cups, I could set this up as 65 to 5 is equal to 7 cups of flour. So 7 goes down here to x. So we could set that up as a however, I don't want to do that. However, I do want you to practice doing it this way so you get used to seeing it this way. So although I'm trying to tie in that this is just a proportional relationship situation, it's just written in a different way. So again, let's go back through. In a word problem, we're going to say it takes, if x stands, what's the depender? Our cookies depend on flour, so our cookies are y. And so if I say y equals, our cookies is dependent on a certain number times the number of flour, a certain number of cups times the number of flour. If I substitute in, I get my k is 13, then I can use that to write the direct variation equation. Y equals 13x. Now I can substitute in the next bit of information. So for 7 cups, cup stands for x, I substitute it in, and that means 91 cookies. Okay? All right, let's look at a direct variation graph. Direct variation graphs don't have a b. That means they're plus 0. So every direct variation equation should be going through the origin. They're linear and they should be going through. So we can do one of two ways. We can make the table, or we can do our let's make the table here. Okay, so when x is 1, let's go -3. I don't think I would pick -3. I would have picked 2, 0, and +2. So when x is -3, it's -1.5. When it's 2, it's -1. It's a half. Now you can see, so I'm going to start with -3 down 1.5. Then I'm going -2 down 1. -1 down a half. 0, 0, 1 up a half. 2 up 1. Okay, it will always go through the origin. The other thing to remember is your K, especially for 7th graders, your K, that's this, y equals kx, right? Your K is always equal to your y over your x, the change in your y over the change in your x. So you'll notice this is increasing by 0.5, and this is increasing over 1, so this simplifies to 0.5, or a half. My K is equal to 1/2. Okay, a proportional equation, a direct variation, will always go through the origin. If they ask you if this line is proportional, you would say no, because it's not going through the origin. All proportional equations go through the origin. All direct variation equations go through the origin. Okay? All right, now they're asking us to write the direct variation equation. If y varies directly, they're telling you we're going to use y equals kx. Okay? Y varies directly with x. Y equals kx. Given the values, to write the equation that describes y in terms of x. Now, they just want it with the k. That's what that means. To write the equation is to find the k. Okay, so I have to substitute in. I'm going to substitute 20 for the y and 5 for the x. I divide them out. I get k is equal to 4. So now we get y equals 4x. That is my direct variation equation. Once I substitute the k in, that becomes the direct variation equation. Okay, pause the recording and try the next one on your own. Okay, let's check our work. I'm substituting 18 and 48. I'm dividing both sides by 48, and I'm just going to reduce it. I know 6 goes into both. 6 goes into that 3 times and 8 times. So it's y equals 3/8 x. That's the direct variation equation. All right. So what happens if they want to relate? Let's take a story and some data. Okay, they're trying to say that there's a relationship between your pinky and your forefinger. That the relationship for the size of your pinky and your forefinger. Okay. So if y is your forefinger and x is your pinky, it doesn't matter what you set up, it's still going to work out. We can set up y equals kx, right? Substitute in any, get our k. Now, let's take an estimate here. If I divide y by x every time, let's see if this is a constant. If it's 1.20, sorry, that's off. And you'll see it's about 1.18. It equals 1.2. And the next one is about 1.21. So you can see that my k, whenever I divide the y by the x, we're about at 1.2. So the direct variation equation would be y equals kx. Y equals 1.2 times x. That's the equation to relate any pinky size to any finger. All right, which of the following may vary directly? Okay, we want to know, can you set this up? Money collected and the hours worked. So hours is dependent on money. So, right, we're going to do hours equals money collected, and we don't know what the, or I guess we should, it's not our hours. Our hours is not dependent. Our money is dependent. Money is dependent on number of hours worked. K being the number, if it's 5, if it's 6. So this is a direct variation equation. We've seen this one, the distance traveled and the speed of a car. Okay, distance equals rate times time. This doesn't mention anything. Let's call it KR, right? Where K represents the time. Okay. Rate times time. Where our T is really our T is really our K, so we would really write that. D equals K times the rate, right? It's very similar. This is really what they're looking for. The area of a circle. So area is equal to pi r squared. Is this very directly? Since it has that second power, it's not. Okay, the circumference of the circle and its diameter. That circumference is equal to pi times diameter. This is in the form because that's to the first power. Pi is like your K. Pi is like your K. Okay, so it would be C equals K times diameter. Okay, and the age of Sam and of his brother who is 5 years younger. So Y equals, okay, if Sam is equal to his brother minus 5. The age of Sam and his brother who is 5 years. No, the brother is equal to Sam. Sam is equal to, sorry, the other way around. It's the brother plus 5, right? Okay, because it has that plus 5, it has your y-intercept, it is not, these two are not direct variation equations. All right, so now let's go to 12.6. Okay, let's do a quick little summary of everything. That was a warm-up from the other one. All right, let's compare direct variation to inverse variation. Our equation for direct variation is y equals kx. Our equation for inverse variation is y equals k over x. And again, we said that this is proportional because as x increases, so does the y, meaning as my hours increase, so does my pay, okay? As the price increases, the profits increase, right? This is an example. Here's how it's going to look in the graph, okay? Now with inverse variation, the equation is y equals k over x. Okay, and what happens here is the x quantity increases, the dependent decreases, whereas one increases, the other decreases. Okay, so if x is the price, if the price goes up and y stands for sales, then my sales is going to go down. And this starts from high and finishes low. Think of your money. Okay? Y equals k over x. Remember we also talked about when you had x in the denominator, it made this funny shape. So our graph for inverse variation has this strange little curve where the graph for a direct variation goes right through the origin. Pause for a moment and write the notes. All right, let's move on. So determine whether the equations are examples of direct variation, inverse variation, or neither. Pause the recording and see if you can figure these out. Now let's check our work. Y equals 2/5 x is a direct variation equation. Okay, for the next one, we're going to have to get the y alone. So I get y equals 7 over x. So that would be an inverse variation. Again, we always have to get the y alone. So I'm going to subtract 3. If I subtract the 3 minus 3, just here alone equals x minus 3. I can multiply everything by -1. And I get y equals negative x plus 3. Because we have that plus 3, it's neither. All right, y equals 10 divided by x. Let's write that in fraction form. So yes, it's an inverse variation. To get the y alone on the next one, I would subtract x. It would be negative x plus 5, so it's neither. And then I'm going to multiply both sides by x, and we end up with y equals 3x. So it's direct variation. The next part says, now, you're always going to build these the same. It says write the equation. Write an equation. But here it's saying y varies inversely with x. So y equals k over x. When you see y varies inversely, you're doing y equals, you're substituting in 4 equals k over 12. I have to multiply both sides by 12. And we end up with 48 is equal to the k. So then to write the inverse variation, I'm writing it 48 over x. Pause the recording and try the next one on your own. All right, let's check our work. Should have started with your y equals kx. We substitute in 15 and 3. I get k is equal to 45, so the equation is y equals 45 over x. Okay, the number of hours it takes to paint. Now, how are you going to figure out if it's direct variation or inverse variation? You are going to, the hours it takes to paint a house varies inversely. So they're saying you've got hours and painters. Painters and hours. So now we have to figure out which one is the depender. Which one is the depender? Does the time depend on the painters, or does the painters depend on the time? That would be the time depends on the painters. Okay. So I'm going to call this H and this P, but this is like our Y because it's the depender. And this is like our X. So now, what we have to say to each other, as one increases, does the other increase? The more painters we use, does that give us the more hours that it's going to take? No. As painters increases, our hours decreases. So we set this up as a Y equals K over X. Because as painters increase, this decreases. If they both increase as, the more traffic there is, the more time it takes, then it would be y equals kx. So we set it up like this, and then we're going to substitute if it takes 10 hours for 6 painters. So I'm going to actually write this as h equals k over p. So I'm going to substitute in 10 equals k over 6. I'm multiplying by 6. 60 is equal to k. So my inverse variation equation is, let's do it with the variables that you need. H equals 60 over painters. Then it says, how long would it take 8 painters? Okay, they don't want to know if you can just write the equation. They want you to write the equation, then be able to use it. So h equals 60 over 8. And then we get about hours is not about, it's equal to 7.5 hours. Okay? So that's how we might see this in a word problem. All right, width of a rectangle with a fixed area varies inversely as length. And they're telling us the way to write it. Width varies inversely to length. If the length is, so we're going to say x is for our length, y is for our width, right? Going to substitute in. If the length is 15, why don't you finish the rest of this up? Write the equation and then find the length for 10. Now check your work. So I'm taking the 90, I'm substituting it in, and then I substitute in 10 for the x. And we get 9 units. Okay. All right, which of the following vary inversely? So does pay varies inversely, to the weeks. So, meaning pay for a fixed salary, that's K, and the weeks worked. So, the more weeks I work, the less pay I get. If I'm getting a fixed salary, it doesn't matter. I can make 80,000, and if I work 52 weeks versus if I work 1 week. So the more weeks I work, the less pay I would get. All right, let's look at the next one. Does time to drive to work and the speed of the car? Absolutely. Let's see. Let's try and draw it. Remember, our equation is distance equals rate times time. So what they want us to do is just relate these two. So get your time is equal, divide by r, distance over r. And so that would be your time is equal to, we could write that as time is equal to, our constant is distance and our rate. Go here, yes, that works. Okay? The area of a square and its side. Okay? Let's go here. I don't think this would be because area is side squared, so how about the number of hours needed to do a job and the number of people working on it? So hours is equal to, this is an important one, you see this a lot, right? The more people you have, the less time it takes, so it would be an inverse variation. We have to always ask us, is one quantity going up and the other is going down? Does the time go up? As the speed goes up, the time goes down. Okay. All right. And I believe that's it for our lesson. Have a great day.